Okay, here we're going to use the same shortcuts to graph a tan function. First thing we have to notice is we are not fully factored within the bracket here, so I'm going to rewrite the function so that it is. I'm going to pull that 2 over 3 out, so that'll be like our k value or our b value. Plus, this part's a little bit tricky. We'll be left with 3 pi over 2. And you can always test if you're right because you can multiply that 2 over 3 back through and you get back to pi. It's always going to be the reciprocal multiplied to the pi that you've factored out. And we still have our plus 2 out here. Okay, so that will once again set up our starting point. And for that, I'm once again, just like the sinusoidal, I'm going to start here and here. So it's been shifted to the left 3 pi over 2. So instead of 0, 0, I'm going to call this point negative 3 pi over 2, because it's to the left 3 pi over 2, comma 2, because it's been shifted up 2 from my vertical shift. That way our axes have been sort of adjusted, so this is no longer the normal xy axis. I've sort of written this function. This is now y equals 2, this horizontal, and this vertical is x equals negative 3 pi by 2. So it's a little bit of a shortcut, but still works. Okay, now let's talk about the period of this function. So the period for the pi function, this is key, is pi over my b value, which is 2 over 3, which equals 3 pi over 2, because I get that by flipping the fraction when I divide by it. So I know my period is 3 pi over 2. Perfect. So what I'm going to do with that is just add and subtract 3 pi over 2 on my x-axis from my original origin part here. So I was at negative 3 pi over 2. That's an easy one. If I add 3 pi over 2 to that, I'm just going to get to 0. So I'm going to put that point here, and that's going to be where x is 0. Conversely, if I subtract 3 pi over 2 and go to the left, that's negative 6 pi over 2, which is negative 3 pi. Again, not too important the scale as long as it's sort of equidistance. So that's negative 3 pi, and that is 0. We should also, so those are going to be our points. Now we also know that halfway between those points, we've got asymptotes. So I'm going to just fill those gaps in with vertical asymptotes. This one's not as well done. Oh yeah, we're still good. Vertical asymptotes through there. And if we want the equation of those vertical asymptotes, it's halfway between. So we know my period is 3 pi over 2. If I divide that by 2, I get 3 pi over 4. So every 3 pi over 4 from my origin points, I will get to my asymptotes. So negative 3 pi over 2 plus 3 pi over 4 is negative 3 pi over 4. And this one will be negative 3 pi over 2 minus 3 pi over 4 is like negative 6 pi over 4 minus 3 pi over 4. So this is negative 9 pi over 4. Not the nicest numbers, but good enough. And you can also do the period 3 pi over 2 to get to your next asymptote. So for instance, I know this first asymptote is at negative 3 pi over 4. If I add 3 pi over 2 to it, that gets me to add 6 pi over 4, which gets me to positive 3 pi over 4. So that'll be my next asymptote at positive 3 pi by 4. And then we just fill in our tan graph as usual. So for the tan, I think it's easier to break the period down into halves instead of quarters like the sinusoidal. But you can still do it in quarters. You just have to include these points in between, right? Not a big deal, but I just like it in terms of half because that covers the distance from the origin or our middle point all the way to the asymptote on both sides, right? We're breaking the one period up into 2 sections so that I can get from the middle point all the way to the asymptote on each side. So hopefully that was helpful. Make sure we Factor our equation correctly so we get our k or our b value, that horizontal stretch. Then find the new period. Set up your origin point based on your horizontal and vertical translations, and then take half the period from there to set up your asymptotes.